We're going to continue on discussing solutions, and now we're going to discuss concentrations of solutions. And um, this is something that we all come across every day if you're paying attention. Um, so, vinegar. You might use vinegar dyeing Easter eggs, you might use it in cooking. Um, it's a 5% solution of acetic acid. Um, Beer, alcohol, wine, all these different alcohol contents are given in a concentration. Um, 5% alcohol in beer, uh, 4.2%, 3.2. All these different numbers mean something. And what they tell us is how much solute there is in a given volume of solution. So remember that solutions, which is what we've been discussing, um, solutions are made up of solute plus solvent. So if you're given something, a percentage, let's say a percent concentration, it's usually uh, a unit, whether it be mass or volume of solute over mass or volume of solution. There are three types of percent concentrations that we use in chemistry. The first one that I'm going to cover is mass percent, and that's grams of solute over grams of solution times 100. So the 100 we ignore for significant figures. Okay, volume percent, which is abbreviated V/V percent, is milliliters of solute over milliliters of solution times 100. And again, you ignore the 100 for significant figures. Lastly, we have mass volume percent, which is M/V percent, and it's grams of solute over milliliters of solution times 100. So we're going to calculate percent concentrations, the amount of solute, and the amount of solutions in these practice problems on page 5. So to calculate percent concentration, work number 1. To calculate the amount of solute, work number 2. To calculate the amount of solution, see number 3. So let's go to the next page. In question 1, we're going to be calculating the mass percent concentration of sugar. So I need to read through this word problem, figure out what's the solute, what's the solution, has it, or solvent, has it been totaled into a solution. So let's look at it. 5.25 grams of sugar is dissolved in enough water to make 22.43 grams of solution. These types of problems require you to read very carefully. And I'm highlighting this. I don't know if you can see it very well. Um, I'll underline it too. This is grams of solution. The definition of mass percent is grams of solute over grams of solution. So uh, I've already been given the grams of solution. I don't need to calculate it. But you're not always given that. Sometimes I would give you the grams of solvent. So to set this up, 5.25 grams of sugar is dissolved in enough water to make 22.43 grams of solution. So this is my solute, and then that's my solution. I'm just going to plug and chug and pay attention to significant figures as always, right? Okay, so 5.25 grams of sugar divided by 22.43 grams of solution times 100, plug and chug, and check your sig figs, right? Okay, so I have 5.25 divided by 22.43 times, sorry, times 100 gives me 23.406152447. But how many significant figures? Look at both of these. So this 5.25 has 3, 22.43 has 4. Our answer cannot have more than 3 sig figs, so I would put a bracket between the 4 and the 0. So I end up with 23.4%. So you can leave it as percent. If you want to, in parentheses, you can put m over m. I'm not concerned. Just know that there aren't any units on that. So it doesn't have units. So it's just 23.4%. Okay. Number 2, how much ethanol is in 125 mils of beer if the beer is 3.2? Okay, so we're calculating the amount of solute. With this type of problem, you really set it up as a conversion problem. And your concentration, your percent concentration is your conversion factor. So this is going to be your conversion factor. And the easiest way I recommend doing this is to take it out of 100. So if I have 100 milliliters of beer, then how many milliliters of ethanol would I have? I would have 3.2 milliliters of ethanol. So this is your conversion factor. To make it into your conversion factor, you're going to take it out of 100. It's 100 milliliters of the solution. In this case, it's beer. So I'm going to put solution, and then I'll put beer in parentheses. And then it's going to be 3.20 milliliters of ethanol. Okay. So this is my conversion factor. Now I need to figure out my starting quantity. My starting quantity is 125 milliliters. So if I just write 125 milliliters, I could potentially cancel these milliliters with either of these milliliters here or here. So I really need to be specific and say 125 milliliters of what? It's 125 milliliters of beer. Okay, that's my starting quantity. I put it over 1. Then I'm going to use my conversion factor. So I want the beer to cancel out. So I'm going to just take this conversion factor and plug it in here. So then I get 3.20 milliliters of ethanol, 100 milliliters of beer. So 125 times 3.2 divided by 100, and I end up with 4. So I have to look at the sig figs on these two numbers here. This is 4 and this is 3. So my answer can have no more than 3 significant figures. So this is going to be 4.00, and the units on that aren't going to be percent. It's going to be milliliters of ethanol. So, sorry, this is 4 milliliters ethanol. Okay? All right, let's work another one. So question 3, I want to make a 7% mass per mass sugar solution. If I have 34.01 grams of sugar available, how many grams of solution can I make? So again, we are not asked to calculate the mass percent concentration directly like in number 1. This is a conversion problem like number 2. In number 2, we were asked for the solute. Number 3 is asking you for the solution. But it's the same approach. You're going to make this concentration into your conversion factor. So it's going to be 7.00 grams sugar and over 100 grams of solution. Then I find my starting quantity, and I'll end up writing 34.01 grams of sugar over 1, 7.00 grams of sugar will be on the bottom, and 100 grams of solution will be on the top. So the beauty of chemistry is that it is a science of conversions. So once you learn how to master the conversion factors and how to get the units to cancel out, there are very few problems that you can't do. So these concentration problems are just an extension of conversion problems. It's just the same thing, getting units to cancel out, checking for significant figures, all of that again. So grams of sugar will cancel out. So getting a firm understanding of this in a prep course will really set you up um, for it's much more likely that you're going to have success in a chemistry course now that you know how to do this. I think that's half the battle in chemistry is just understanding, oh, I have to set up these conversions. Now I can do that. Okay, so we have 4 sig figs, 3 sig figs. Uh, so I get 486 grams of solution. Okay, so unless you're asked directly, like you were in number 1, what is the mass percent concentration of the sugar, you will have to set these up with a conversion factor mindset. And the conversion factor will be given to you in the form of a concentration. So you have 2 more problems to work. I want you to try to work questions 4 and 5 now on your own. I know 5 is 2 parts, so it's really like 4, 5, and 6. But try to work those 3 problems. Get them set up by yourself, and then come back and check with me. All right, so on number 4, your conversion factor is going to be 5 mils of alcohol per 100 mils of solution. With number 4, you really have to read carefully to know that the 75 milliliters is solution. So 75 milliliters of, it's almost like take something and block it out so you can see that it's just solution of solution. So 75 milliliters of solution times 5 milliliters of alcohol divided by 100 milliliters of solution gives you 3.75 milliliters. And the number of significant figures, you have 2 here, 2 here, so you can only have 2 significant figures. On question 5, it's a 2-part question. Your conversion factors for A, 12 grams of glucose per 100 milliliters of solution. Remember that with mass volume, sometimes it can be written WV, so just be on the lookout for that. So WV or MV, grams per milliliters. So 12 grams of glucose per 100 milliliters of solution, and then 2 grams of potassium chloride per 100 milliliters of solution. So with A, you're starting off with 100 milliliters of solution. You're going to multiply that directly by your conversion factor, and you'll end up with 12 grams of glucose. And then in B, you're going to take this conversion factor and multiply it times 75 milliliters. So you end up with 1.5 grams of KCl. Both of these have 2 sig figs because the starting quantities have 2 sig figs. What I want to encourage you to do now is to work homework problems involving the concentration problems. These can be challenging and require practice. Like I said at the beginning, they require more practice than probably anything else that we've done before. Part of it is just careful, slow reading and tempering your anxiety. You know, that feeling you get when you see a word problem and you think, oh my gosh, I don't know how to work this. What am I going to do? That type of thing. So you have to stay calm, read the question, be methodical about it. What am I given? What do I need to find? So you can do it. You have, by all means, worked very hard this whole semester. You know how to do conversion problems. So it's just the next step. So I will conclude this lecture now. The next lecture will also cover concentration, but a different type of concentration. That is not a percent concentration. So we have 4 types of concentrations to learn about. We've learned the first 3% concentrations: mass, mass, volume, volume, and mass, volume. And the next lecture will cover molarity, which is not a percent concentration. So I wanted to keep those lectures separate so there's no confusion, or as little confusion as possible. So, but keep practicing, keep up the great work, and you're almost done. All right, until next time.